Hey yo YouTube, it's a happy day today because the PCBWay fairy showed up. So thank you to our wonderful friends at PCBWay for sending me these happy little boards that are probably in this box. I've cut the tape but haven't opened it yet, so let's just tear into it. Let's see what they sent me this time. We have stuff. What do all those numbers mean? Those numbers mean we have a Z80 accelerator board for the C128. Yes, it's a beautiful thing. So I talked about this a little bit in a previous video. I won't belabor it right now. I just want to get to building this thing. So I'm very, very excited to get this little bad boy fired up. So I've already made myself a little care package. This should be all we need. A gal 74LS74 and some sockets and some pin strips. Here, we'll zoom in a little on all that. And yeah, I think this is going to be one of those pretty easy boards to do. Put the pins on first, the sockets on next, and then we'll wire this thing into a 128 and see what it does. So let's get building, eh? Alright, let's get rolling here. So this project didn't come with step-by-step instructions or anything like that, but it should be pretty self-explanatory and straightforward if we look at the schematic for a second. So I need to figure out first which set of 40 pins the pin headers go on versus where the socket goes. So obviously the socket's going to go to the Z80 and the pins are going to go into the board. So if we look at the schematic, pin 6 will be a dead giveaway. The clock pin is basically what we're manipulating to change the clock that's ultimately getting to the Z80. So pin 6 for the CPU socket will go to jumper 2 here, and pin 6 from here is just gonna go to somewhere else. That's probably, I guess that's the original clock. So pin 6 is still going to be the original clock coming in, and you know, pin 6 on the pin headers is going to be the original clock coming in, so you can toggle between 2 meg and 8 meg mode. So let's figure out which pin 6 goes to jumper 2, and that is where we will put our socket. So pin 1 is a little square guy here. So 1, 2, 3, 4, 5, 6. And JP2 is not that one. It is that one. Okay, so that is where our socket needs to go. So I have this board in the wrong place right now. Gotta slide him over a bit. Like that. So now 1, 2, 3, 4, 5, 6. Measure twice, cut once kind of thing. Alright, so those open pins are where, or those open pads are where our socket's going to go, and the pin should go in here. Alright, let me blob these things in place and go on from there. Alright, the pins are all blobbed in place. I trimmed the one on either end just a hair so the socket will clear a little easier, and that sits down good and flush. So we have, you know, little square guy is pin 1, and I think there's a little notch, yeah, there, you can kind of see that, so we will align our notch that way, and we'll throw this socket on next. While I was on a roll with the 40 pin socket, just kept rolling. Did the, what is this, 816, that's a 24 pin, that's, you know, 3 8 pins I stacked together, because why not? And 14 pin for the LS74 LS74, and there's just a couple of passives that need to go on here next. So a couple of 10K resistors and 0.1 microfarad 104, whatever you want to call it, you know, typical decoupling cap will go in there. So you know, him there, it looks like, yeah, pop him in there, and then resistor and resistor, and then a couple of jumpers, and I think we're done. And there's a couple of resistors and a cap fitted. Now we need Let's see, JP2, 1, 3, so we need 3 sets of jumpers, a 2, a 2, and a 3. And these I'm going to leave unpopulated for now. That's where you pull in some other signals, like 1 megahertz and the dot clock. And yeah, so I don't know exactly how that's going to get wired in yet. We got to see what real estate we have to work with on the board. Hell, I don't even know if this thing's going to fit in my board. So we'll just hold off on doing anything there, and we'll just fit some jumpers on JP1, 2, and 3, and then see if we can get this thing in a machine. Alright, we've got our shiny little red pin headers in place, so we can do jumper things later as needed. And we got to program a PLD now. This is super simple with the TL866. So we're using a 22V10B. Hopefully a 25 nanosecond part is fast enough, and yeah, is what it is. We'll try it and give it hell. So, all right, what are we gonna do? Let's see. We downloaded this file from the repo, the JED file, and here, let's get rid of this. We have the JED file loaded here in our XG Pro tool, and we have selected the correct chip. So if we hit program and the contacts in my programmer are not dirty, this should work. This thing's been giving me fits lately, but let's see. Hey, it worked. Yay. Alright, that's it. Super simple. We'll install this on the board. Now, I guess it's time to clear off my cesspool of a bench, get a machine, and actually install this stuff in a computer. So let me clean up a bit, and we'll continue. All right, we have a test subject. It seems to boot in 80 column mode. It seems to boot in 40 column mode. All right, we have a working computer. So I will tear into him, and let's see if we can figure out how to squeeze his board in there. Okay, now this is the part I've been afraid of, because we already have a ton of shit going on over here with the extra pi and the MMU thing, and yeah. So this is, we're gonna have to get creative here, and I doubt the lid'll go back on. So this might be better suited for a D machine or something, but we're gonna give it hell and see what we can do. So here's our Z80. I don't even know what speed this part is rated for, but I do have a brand new 8 megahertz part we'll grab if we have problems or whatever, but we'll run this one and see if he keeps up or overheats or whatever. So let's get our board off of the breadboard here, hopefully without bending anything. Come on, buddy. Don't want to break you. I just made you. Get the hell out of there. Alright, there we go. Here is our daughter board. There is pin 1, and there is pin 1. So it needs to go this way. And it needs to hang over this way a bit. So we are not going to clear our MMU board. So I'm wondering, we're going to need access to that underneath there. So I'm wondering, do we stack this guy way the hell up there? No, that's going to be terrible. I wonder if we raise the MMU one click, we stack in one extra socket, if I can find something, and will he fit underneath? I think that's the best way to go. Alright, we're going to give that a shot. I'm going to pop him out, we'll pop him in, and see if we can raise him up. I think that's the plan. Who the hell knows? Let's see. Alright, with the MMUs out, this guy definitely squeezes right in there, but there's going to be some overlap here. Fresh out of 48-pin sockets, so we have some strips. I'm just going to put an extra layer of strips on the bottom of the MMU board and see if that gives us enough clearance. Alright, so even with 2 stacks of pin strips, one on top of another underneath the MMU, it's still not going to clear. maybe if you flush mounted the Z80 and the 74 to this board, it would. So I think we're going to flip our roll here and put him back in the socket and stack a bunch of stuff under him and see if we have better luck getting him above this guy, because I already flush mounted the gal that's on the MMU. I think it might clear a little easier that way. So let's we'll give that a shot. Hang on. Now we're kind of screwed going this way too. So the MMU board hangs out over the Z80 pins. There is no way to get this in here. These two boards are not going to work and play well unless we lift him, the MMU board, way up high. We're going to have to stack at least 3 rows of shit under him. He's going to be way the hell up here. So if you want this to actually fit in a case, you cannot run both these mods at the same time. Kind of unfortunate. You know, I could see gluing these two projects together, and I don't know how many gates are open on each of the 22 V10s, but I assume there's a few. I wonder if these two projects can be combined to a dual MMU Z80 accelerator thing, but for now we can't run the 256K mod. It's just not going to work. He's got to come out or get stacked way up. Let me see if I can stack him high enough, because I don't feel like I'm doing all this shit. So, hang on. Okay, did a little bit of prep work here. So, our Z80 board's in the socket, notches down. Pin 1 is, on the south side here. Over here, the little green wire I have tacked onto the board, not to be confused with that green wire, but the little green wire is for the dot clock, and this blue wire is for one of the 1 megahertz clocks that's in this wonderfully engineered machine. But there's a version of the 1 megahertz clock that gets brought together with a resistor and something else, and it's called D1MHZ on the schematics. That's the one that this project says to pull from. So that is available on the north side of R102 here. That comes from pin 11. Can you move him a little? Pin 11 of the 373 here. But you really can't get to pin 11 because it's under there. And yeah, the trace just goes right over here. So it's just as easy to grab it off of the north side of 102 there. So that's where we'll put our blue wire. And the green wire, that's the dot clock, will go to pin 6 on our expansion slot back here. So, yeah, that, and I have 3 rows of pin headers on here, which should make it tall enough. The case will never go on. Well, it is what it is. I just want to see this thing go. So, yeah, let me get these 2 tied in where they need to go, there, and the cart slot, and it might work. Oh, we'll have to install some jumper caps. So yeah, let me get the wires in, then we'll figure out the jumpers. And there's our blue wire from the north side of 102 there, going to the 1 meg clock. And our green wire on pin 6 of the cart slot. That's our new 8 meg clock. Now, moment of truth, is this frickin' bodgery gonna get in there? I think it's in. Well, it's a tower of terror, but it's in. Probably should have put that jumper on first, but I wonder where it needs to be. Let's find out, shall we? There, we can use one of the unpopped boards as a cheat sheet. And where is it? Yeah, it goes that way, so it's up here. So 1 and 2 is 8 meg, 2 and 3 is 1 meg. Or 2 meg. I can't really see that. But yeah, so fast mode is going to be jumpers 1 and 2. Yeah, we're just going for the gusto. We're just going to put this thing in fast mode. And I'm going to have to squeeze the CPU in there yet, so he's got to come back out. But at least test fit was good. So, alright, we'll pop him out, pop some jumpers on, pop the CPU in, and it might be ready. Alright, so if I'm reading this right, where's a pokey? This goes on 1 and 2 for 8 megahertz mode, I think. Yeah. 1 and 2, 8 meg is what it says. And then open is 2 meg or closed is 8 meg, so we closed him. And then open is fast and closed is slow, so we left him open. Stack O MMU 3 deep seems to clear. You know, if we flush mounted everything and used a 90 on these guys, or at least on this one, you know, to stick them straight out the side, I can probably drop this down, but I don't think it's going to matter. I think stacked up at all, it's not going to clear the case. So this is just kind of a test run. We'll wind up putting this in a D case with a deleted 1571 mechanism, I think, because this barely fits in the D case as it is now. So I think we're going to yank the 1571 out of my D, so all this stuff can actually fit inside a computer, but in the meanwhile, we can test it on this thing and see how it does. And the CPU is an unknown. I put a heatsink right over the label, and I have no idea what the hell it's rated for. So we could remove the heatsink and look, but fuck it. Let's just turn it on and see what happens. So let me get rigged up to some capture stuff and a scope and whatever, and turn it on and hope for the best. Alright, no keyboard or anything, but we have power, and we have both our 40 and 80 column connected. Alright, yep, good. We have the camera pointed over here. Keep an eye out for smoke, and well, that's a plus. Alright, it actually turned on, and it's hanging booting from drive 8 because I don't have the SD card hooked up to the Pi. That's okay. Alright, it booted. So I gotta get a keyboard on this thing so we can try it out in Z80 mode and see if it will boot to CPM. Alright, here we go. It's almost looks like a computer. Hang on, let's yeah, it's a little lopsided because you really can't tell from this camera angle, but I don't want to touch this thing right now, but it kind of lays on top, and the MMUs are right there, whatever. So let's do that, turn them on. Nothing. That ain't good. That's not good at all. Where do my captures go? Alright. Just a loose cable somewhere, I think. Alright, very good. So let's find CPM. Let's load the RU stuff. And then mount him on 8. And let's mount him. Oh, let's not mount him. Let's mount Wordstar on the second drive. Yeah. And should be all we need to do to get ready. Let's boot. And we'll let this record in real time, see how fast it boots. It seems peppier. Alright, let's go to B. Now floppy access is still floppy access, so that is what it is. But once the program loads, we'll see how it behaves. Remember the other video, the redraw was freaking horrific. And then we'll try to load something from RAM drive here in a minute. And we'll pause while this loads. Huh? Maybe? I'll let it ride. Well, that's definitely faster than it used to be. We'll have to do a head-to-head or something at some point, but it's noticeably quicker. All right, let's open a document. Oh, crap. No. It wobbles a bit when I type on it. It's alright. Oh, what the crap. Alright, just create a new document. Fuck it, come on. Man, D71 access is friggin' slow. Alright, well, the redraw. See, when you hit enter and it redraws the margin line or status bar, or whatever you want to call it. It's faster. I wouldn't say it's the fastest thing in the world, but hey, it's faster. Alright, let's try loading something off RAM drive. Let me figure out how to bail out of here and we'll do that. Alright, out of sheer laziness and stupidity, not knowing how to use Wordstar, I just rebooted the friggin' thing. So let's go... Ooh, bad habits. Let's go to the RAM drive. And that was... work drive M1 is commands. M2 should be games. Yes. Alright, that's pretty fast. And that redraw on the top row goes pretty quick. Yeah, this is a whole lot faster than it used to be. Alright, neat. Well, that's a good thing. I wonder if we can squeeze 9600 baud out of this thing now on... Can you see it? Yeah. On the Link 232 Wi-Fi cart. That would be a neat trick. So we'll have to put in the port expander, reboot again, all that shit. Let me do that. Let's see if we can get some more serial port speed out of this thing. Alright, we're booted back up with our Swift Link, Link 232, whatever you want to call it, cart, and our Ultimate 2. And yeah, I wonder if we can achieve higher baud rates in our life now. So let's run qterm SL. Alright, no corruption. I don't know what baud rate we're at though. Let's do ATB 9600. Alright, then what was it? Control OB 9600. Nah. Nah, it still sucks. So, alright, something else to deal with there. In fact, I think it's worse now with the Z80 running faster. So maybe it's some tweaks to the terminal program, maybe there's a better terminal program, or some magic configuration settings, a flow control or something, but yeah, this is definitely worse. Worse than the last video. Alright, well, anyway, we have a faster computer. And it kind of almost works, except the case is wobbly. It doesn't fit in here. So I think next we're going to take this out of here and install it in the bigger cased 128D. That is going to require deleting the 1571, but that's okay. I got a plan for that as well. And that gets us a bunch more real estate inside that chassis to add even more shit later. So I think I'm going to wrap this for now. This is like the third video I've done, and I've posted none of these. So I got to go splice a bunch of stuff together, upload the stuff so people can see what I've been doing, and we'll take it from there. So anyway, for now, we have a mostly working machine, even though it looks a little funny and lopsided. So see you next time. There's more to come.